7.
But you can't bend on it.
6 or like 2.
How much money would you?
So then that you divided by sure.
We just have to see how many $1 bills.
I am going to do this square root problem here. And I am also going to do the ones on the back. All right, so I know the back ones were pretty hard. They were?
They seem pretty easy, and that kind of scared me.
Okay, well maybe you just really got it then. Okay. So what is the first thing I'm gonna do on this guy right here? Make it x to the 1/2, and then yes, derivative. All right, so what would the derivative of that be?
1 plus 1/2 to the negative 1/2. And you said equal to 0?
And we are gonna set this equal to 0. All right, so let's solve this. What am I gonna do first? Subtract 1. All right, then what?
Divide the 1/2.
What's the same thing as reciprocal? So it'd be 2.
Are we gonna have a problem like that?
Maybe. All right. What does a negative sign mean?
This goes on the bottom.
It goes on the bottom.
Is this the back?
No, this is the top. The right side's that going down.
Interesting.
All right, so
Where'd you get the?
Oh, it's times 2.
I thought you were doing
move this up,
no.
down, like we can see from.
Yeah, sorry.
Bless you.
All right. So I don't like fractions, right? So instead of having a fraction here, I'm going to cross multiply. I'm gonna put it up here. So 1 equals negative 2x to the 1/2.
What would you have done if you hypothetically did not know how to do that?
How to cross multiply?
Or you did not think to do that?
The other thing that you could do, ignore this. The other thing that you can do, which some of you might like better, is, okay, we're gonna multiply this by something to make this guy a 1. So what times this would give you 1? Negative 2. And if you do it to one side, you have to do it to the other. And that will make that guy an x. And then you
so
get,
much easier.
okay, well then we can do it that way.
So what's
Wait,
never
mind.
I was
What
thinking
did you
about.
just do?
Go back to that.
I'll do both ways.
Coach, that's because when you have an exponent on the outside of parentheses to an exponent on the inside, you multiply.
Wouldn't it just be 1 over 4?
So you multiply by.
Yes.
So much easier.
Multiply by what? What are you doing?
All right, so let me back up. I'll go back and do this other way here, but the way that probably is a little bit shorter if you know, if you're good with your exponent rules, which I don't know. I don't know which way is better. I would probably do it this way, but if you have x to the negative 1/2 equals negative 2, and I know I want to get x by itself, so I'm gonna say, okay, what do I have to raise this guy to make that exponent go away? A negative 2, because negative 2 times negative 1/2 is a 1. Does that make sense? If you do it to one side, you have to do it to the other.
This is still solid for right?
Right. All right, so negative 2 raised to the negative 2. Well, a negative goes on the bottom. And so then something squared, you know, negative 2 squared would be negative 4. Negative, sorry, 1 over 4.
Okay, but that's like not.
What's
getting
the
it.
answer for the other one? Yeah, it's not an answer. That's just the point. Doesn't put it in yet.
Critical point.
I know.
So
But the
you're gonna solve
critical
it,
point.
you
Yeah.
can still do that.
Oh, I see what you're saying.
Oh,
Maybe
yeah.
one of those.
Maybe you did it wrong.
I guess the homework's wrong. We just gotta get rid of it.
No, I mean, I did it differently on.
She's trying to figure out where she went wrong.
You are gonna realize that.
Wouldn't it be one of those canceled? Oh wait, no.
Get factor out of the.
Wrong.
do it the other way and see if it works.
This way?
Yeah.
It's the same thing.
Probably is. We should recreate. Watch
And
it.
square it. in 1/4.
Recreate.
Yeah, it is.
What number are we on here?
I don't know, I'm messing up.
Yeah, you are.
So, Billy, we're working on this.
Is that?
Because it's hard.
Is that, oh, how much did you?
Yeah, if you can't do it, how do you expect us to do it?
It's just not matching up any of my answers.
I can't, like, we could put it out.
Try doing the other.
I'll look at it, let me look at my key, because I didn't run into that issue when I did my key. Let me look at my key later. Let's do the ones on the back. I'll come back to that one and explain.
There's
it
a
later.
note that says, make sure to check the domain.
Yeah, the domain 0 to infinity though, that shouldn't matter. Let me look at my key. You don't have a square root one on your quiz, so don't worry too much about it right now. Okay. So on this guy right here, it says, if we are twice differentiable, which of the following statements can be true? All right, so first of all, it's talking about f prime. And so is this function increasing or decreasing? Increasing. So since f is increasing, what does that tell me about f prime?
It's also increasing.
No.
Decreasing.
No.
It's
It's positive.
It's positive. So I can at least narrow it down to C and D.
Hold on. Hold on.
And then it's pretty much never D, so I get.
Wait, did we just give up on the outcome?
I need to go back and look at my key.
Yeah, we did.
I'm gonna look at it while you're doing your quiz.
Did you
Wait,
look
what
at,
did
did
you
you tell
just
if it was increasing by the top or the bottom?
The numbers here, they're, yeah, oh, the bottom, the Y values are getting
Wait,
bigger
what did you
So
just
that
do?
you knew
They're
the
building.
F prime value was positive.
because your numbers are getting bigger, so your F is increasing, which means F prime is positive.
So,
Does that make
Is that
sense?
just common knowledge now?
what?
That's what the derivative test is, or the increasing, decreasing that we
Both
did.
increasing, it has to be
Well,
positive
it's
and
gotta be
increasing.
increasing then too, right?
Oh.
Yeah, positive can't be decreasing.
Yes, it can.
No, how can positive be decreasing?
You're positive, but your line is decreasing.
Oh, okay.
All right, so,
But you're
That's-
able
is
to-
that like
Oh,
on
yeah.
the top line?
right,
Can you just do rise over run and determine if the slope is increasing or decreasing or? the-
yes, exactly, and that's exactly what we're gonna do. So we're gonna do rise over run here. So what is the change from here to here? 5. What is the change from here to here? 4. What is the change from here to here? What is the change from here to here? So is your change increasing or decreasing?
Decreasing.
Decreasing. So we are positive, but we're decreasing.
Interesting.
Holy
When in doubt, go with-
I don't understand that.
That was a pretty tricky one. These two were tricky questions.
Why? I'll do that.
All right, let's do
Is
2.
the quiz like a brown?
Yeah.
Take it.
These are just AP style. These were like some hard AP questions over the increasing, decreasing concept that I thought I'd show you. All right. So let the function f be 4 minus x, and g is a function with the derivative given by this. And we want to know when is g decreasing. So we want to do a number line. To find the critical points on my number line, what do? Derivative instead of equal to what?
0.
0. Do we have the derivative?
No.
Yes, it gives me the derivative of g. This is the derivative of g.
So it's plug it in, right?
And so what are we setting the derivative equal to? 0. And so what this is saying is I want to find when f of x equals 0. I want to find when f prime of x equals 0. And I want to find when x minus 2 equals 0. Does that make sense? Each factor gets set equal to 0. All right, well, f of x is 4 minus x. So that is going to be at 4. What is f prime of x?
Take the derivative of 4 minus, so it's -1.
-1. Will -1 ever be 0?
No.
No. And then what will this one be?
X equals 2.
2.
Wait, how did you just get that? How did you get that?
How did I get what? -1 here? Derivative of this guy?
And then.
All right, so that gives me my critical numbers. Now, how do I figure out if we're increasing or decreasing?
Positive, negative.
Yeah, figure out if it's positive or negative. So I'm going to test 0, 3, 5. And what are we plugging it back into? The derivative, which is this guy right here.
Didn't you say something like negative function?
When you're doing extreme value, when you're trying to find absolute max and min, you do, but if we're just trying to figure out if we're increasing or decreasing, we do the derivative. All right, so g prime of 0 is gonna be f of 0 times, what is f prime always gonna be? -1. No matter what, f prime is -1. Does that make sense? And 0 minus 2. All right, what is f of 0? When you plug 0 into the f function, 4. All right, so positive times negative is going to be positive. Does that make sense? All right, so now we also have to plug in what test number? 3. So we got f of 3. F prime will always be -1, and then 3 minus 2. What is f of 3 going to be? 1. So yep, so negative, so decreasing. So I know I'm decreasing from 2 to 4, and then just for the sake of time, when you do 5 as your test number, you get positive. So which answer is it going to be? C. Okay, I'll look at this one.
Don't worry about that one.
No, it's not on your quiz, so don't worry about it. All right, if you have a quiz, turn it in. Anybody else have a quiz?
Coach, I can't do the homework because that problem is the same one. That one that we can figure out.
Oh. I want to know what I am doing wrong, but I got to do notes first, and then I'll. Do you want me to go over the quiz, or we think we're good? We got it. Okay, I'm gonna. You're increasing from -infinity to -2, and then 2 to infinity, and you're decreasing from -2 to 2.
So there's 2 decreasing.
No, one decreasing, 2 increasing. Okay, get your notes out. Your test is, oh, that's not. Where's my calendar? On Monday.
That's on Monday, but we don't have a review day.
We have a test on Monday?
We don't have a review day.
Oh, I mean Tuesday. I forgot I pushed stuff back.
Because I have a final.
Tuesday.
What's our final gonna be for you?
We're not doing a final. But you have to come to class on final day.
So we're not learning on final day?
We are. We're gonna do notes on final day.
For how long?
Yeah, we can play Catan after notes.
I think you don't want to
We're
lose.
taking notes for 2 hours?
No, we're gonna do a regular 45-minute class period, and then if you want to play Catan.
I think you still want to lose against me.
Wait, can we go home after the 45 minutes?
I wish, but no.
What if you have a
Are you
prostate
gonna-
exam?
We go to the bathroom.
What, Daniel?
What if you have like a prostate exam like 5 minutes after the 45 minutes?
Will you count the final as like exemption or like a
Exemption.
So you're just calling our final exemption? Can you tell Dr. Hopkins that you're exempting our final, so she'll exempt our final?
We're gonna keep the fact that I'm not giving you a final on the DL, because I don't know if I'm actually allowed to do that.
doing a final?
Yeah.
Yeah, Coach, how come we don't just talk
Something
about
on class.
But you still have to come to class.
Can our attendance be-
No, we're coming to class and doing notes. A regular 45-minute, not like a 2.5 hour, like a
Do
regular
you have a
45 minutes.
schedule? So do we leave after?
Yes, the schedule for finals is silly.
Just tell me after that.
Yeah, I think I threw it away. I'm hoping they change the schedule, so I'm not
I
sure,
heard
but
we have 4 tests on one day.
on Thursday you have 4 finals.
Is there a movement to change the final schedule?
I've been told to tell you if you want to change the final schedule, to have you and your parents email your APs or your counselors, probably your APs though. I don't know who the APs
I
are.
don't know the APs either.
Email your counselors. I can tell you your APs. I just don't know. off the top of my head. So there are 4 finals on. You're just straight finals from 8:30 to 4 o'clock on
That's
Thursday.
ridiculous. What if it's like this 45 minutes, like it's from 8:30 to 9:15, which makes.
No, they're all like, you have 4 classes.
It's 2 hours. It's 2-hour final period, so you're in class for like 2 hours. Maybe. I looked at the schedule yesterday and like one final was like 8:30.
Is this good for them?
What? That's not.
Here's the final schedule. So our final is gonna be on Wednesday, which we're not doing a final, but you do need to come to class.
That doesn't really make any
Why is-
sense.
Schedule looks so different. Like, why do it look so dumb now?
Why is it all
I don't know.
different colors?
I already complained. I
Yeah,
complained to
I'm
my
so-
supervisor. I complained to my IS.
We have so confused.
Yeah, I don't understand. this.
2 class, 3 class.
What is four, does 2 class mean second period?
Yeah.
Yeah.
Why is it all like
Why would they
scratched
not
out
just
and
like
crap?
first period?
I don't know.
What's bothering me? I don't even know.
Why is it so weird?
Okay.
I don't know.
Why
I
would
don't
they do
Who
class?
do I? who do I
three?
Because this year is all about power struggles, and there was a
No.
committee who made this, and now the committee does not want to admit that they're final subs and
Who's on the
make a
committee?
better one. I don't know who was on this committee, but
Who
but I was told that there was a committee who made this.
Who made
And
it?
so,
What are their addresses?
Wait, can you put that one? Just in case it sticks.
What is 3 classes?
Wait, why are there the first 2 classes on one day?
Murder one.
On last day? This is so confusing.
I don't know.
Don't have to come. along,
Also,
so
like-
that's all I'm saying.
So make it murder.
It's so unnecessary.
It's dumb. I agree. It's dumb. I hope it changes. If it does, I'll let you know. But as of right now, that's what it is. So
So you think there other classes aren't gonna let us exempt the finals, so y'all are allowed to, or y'all are allowed to exempt finals?
if seniors are allowed to exempt, but you have to have no unexcused absences and you have to have an 85 or above. I'm not checking that for
I
y'all
have 16.
as long as you keep it on the DL and I don't get in
I have a
trouble.
ridiculous amount of work.
It's so bad.
Can
Yeah,
you go to
so-
Saturday school and make up those absences?
I don't know how that works.
What's my son's going to do
This week.
Really?
this weekend?
Okay.
It's like 8
Yeah,
to 12 or
you
something.
understand also.
What are we learning today? What?
No, never mind, I forgot.
Do I want to sing?
We're gonna run through the
Never
trial.
mind. But he probably.
We're doing the first derivative test. All right, so focus up here so we can do notes. Today, we are going to talk about the first derivative test, which is something we've already done. It is literally what we did yesterday, but we are going to use it to find my relative, Billy, extrema.
What does that mean?
What is extrema?
The absolute,
Not absolute, just the maximums.
the absolute extrema is absolute.
Yeah. So relative is just all of your max and mins.
Isn't there only one maximum?
No, you could have multiple max and mins.
How?
So these are maxes.
Oh. If you're different numbers,
Yeah, but they're both maxes.
it's like a peak or something.
Uh-huh. And these
Man,
are mins.
mans.
Yeah, it looks like man. I don't know where my whiteout went. That's okay, it's not bad. All right. So we're gonna use the first derivative test to find all of the maxes and find all of the mins. And put it on a number line. Let's see. Okay. To do this, you find a critical number, which once again is where f prime equals 0 or f prime is undefined. And we're gonna put it on a number line, just like we did yesterday. All right, so your critical numbers are gonna go on your number line. Oops, hold on, don't write that.
It's behind your projector. No, that thing.
Oh, thank you. It just shows you what the max and min is, what you're finding.
But technically, isn't that not a max or a min if it's not the max or min full graph? Or is it just?
It's not the absolute, but it's a relative
It
max.
should have a different name. I think of maximum as the.
Absolute. That's why you have absolute and relative. All right, so if f prime is positive, my function is increasing, and if f prime is negative, my function is decreasing. And the reason why that is important is because if we go from increasing to decreasing at this critical number,
Oh, that's a math.
that would be a max. And if you go from decreasing to increasing at that critical number, you have a min.
So this is the exact same thing that's saying that. if
We're
they
finding the
alternate-
max and the min now.
if they
so-
al- But it's, but like it's the same process, except it's just saying that if they alternate, that point at which they alternate is the max.
Yes, exactly.
So really, it's just the same thing.
It's the exact same process that we already did.
It's just another understanding.
We are just finding the max and the min,
So why
yes.
is it another whole thing? Like, why is it not part of the last thing?
Because we didn't do max and mins yet.
Yeah, but it's the same thing, just a different understanding.
Okay, well, you're gonna practice it more.
And why does it have a different name?
The other thing, we never gave it a name. The other thing was called the first derivative test, but we just did increasing and decreasing. The first derivative test helps us find extrema, and it also helps us find increasing and
It's
decreasing.
really the last thing we did. is the same,
Okay. For the justification, and this is important. All right, the justification, if you have to justify whether something is a max or a min, you have to be specific. Minimums are because f prime goes from negative to positive. Specifically, maximums have to be from negative to positive. Sorry, minimums, thank you. Minimums are from negative to positive. Always, they have to be. So if you're justifying a minimum, your f prime goes from negative to positive, because that's how the number line goes, right? If you're talking about maximums, f prime goes from what to what? Positive to negative. All right, it has to be that way. Minimums go negative to positive, maximums go positive to negative. Now, that's not something you have to memorize because I always draw number lines. All right, so for every problem that I have, whether I'm given a graph or something, I like to draw number lines. I like to put my critical points. I like to draw my arrows. And I feel like that kind of shows me what's happening. And that way you don't have to memorize this rule because you can just always draw a number line. All right, note that if H of C does not exist, H equals C cannot be an extrema. So for example, if at C we have a vertical asymptote, right? So if at C we have a vertical asymptote, there's not actually a point there, C cannot be an extrema. Whether you go from increasing to decreasing or not, C is not an extrema if you have an asymptote there because that point does not exist.
I'll never understand what some of this stuff like that is said. Like does it need to be said?
Elijah.
Like, I mean, yeah.
But it's not like duh to everybody.
The people that are gonna be reading it.
It's so that if the point doesn't exist, it can't be mentioned.
All right, but if it's, you have to,
It doesn't, you can't do, no.
but when you're working a problem, it might not be something you think to check.
So I'm gonna try and solve the problem after, you know, they're gonna want-
All right, anyways, know what the question is asking for. If it says, what is the maximum value? What are you finding?
The absolute, the
No.
relative.
Is it the X or the Y value for the point?
Why?
The Y value. If it says, what is the maximum value, you're looking for a Y value. If it says, where is the maximum value? X value. Bless you. All right, and we talked about that when we did the extreme value theorem, right? What it is the Y value, where it is the X value. All right, so let's do some examples. Find the relative extrema. So because it says relative, I'm thinking first derivative test. If it says absolute, you're gonna do the EVT where you find all your candidates, plug them all in, you normally have endpoints. Does that make sense? So this is very similar, but it's relative, so we're gonna do the number line in the first derivative test. All right, so find the relative extrema. F of X equals 1/2 X minus sine X on the interval from 0 to 2 pi. Now notice we have parentheses. So is this a closed interval? No, this is an open interval. So your endpoints don't matter and are not extrema.
So those points right there aren't.
Because they're not in brackets? They're not in brackets, so they aren't extrema. So only closed intervals can be absolute max and mins. If you're talking about relative, endpoints don't matter. Does that kind of make sense? So relative endpoints don't matter. Absolute, you have to check the endpoints. And because these are not brackets, it's an open interval, so your endpoints are not included and it's not part of your absolute extrema or relative or any kind of extrema, okay? So all this saying from 0 to 2 pi is just saying when we're looking at our unit circle, we're just looking at the whole circle. We don't have to go around and around and around the circle. That's all the interval there for 0 to 2 pi is saying. Does that make sense? So let's do the first derivative test. I have my function. What do I need to do? Take the derivative. I don't have to do product because they're being subtracted. So what's the derivative of 1/2 x? 1/2. And what is the derivative of negative sign? Minus cosine. All right, so what do I do with my derivative? Equal to 0. Okay, so now let's solve this for cosine or for the x. So I'm going to minus the 1/2. So I get negative cosine x equals negative 1/2. And how do you get rid of the negative? Divide by negative. So I get cosine x equals 1/2. That's when you're going to go to your unit circle. Is cosine the x or the y value? The x. Where on my circle is the x value a positive 1/2 pi over 3 and 5 pi over 3. Does that make sense? Okay. So my two critical points are pi over 3 and 5 pi over 3. And so I'm going to put those on my number line. All right, and then I'm going to do some test points. All right, so a number on the left side of pi over 3, I'm going to say is pi over 4. You can't do 0 because it's not included. Between pi over 3 and 5 pi over 3, I'm going to use pi because that's a pretty easy one. And on the other side of 5 pi over 3 is going to be 7 pi over 4. You can't use 2 pi because it's not included.
Could you just do like a whole number? No.
You don't want to because if this is non-calculator, you can't figure out what like cosine of one is.
Oh.
You know what I mean?
Yeah.
All right, so I'm going to come up here to my derivative. And I just need to figure out if we're positive or negative. So let's look at the pi. What is cosine of pi? Negative 1, right? 1/2 minus negative 1. Is that going to be a positive or a negative number? Double negative. Minus negative 1.
Positive.
So positive. Does that make sense? So when you plug pi in here, you get 1/2 minus cosine of pi is negative 1. Oh, you can't see that anyways. All right, so now I'm going to plug pi over 4 in, and kind of like what Daniel said, it's not a good rule to follow, but if you are stuck, most of the time you do alternate. So if you are stuck, guess and alternate, okay? But obviously, try to do it first. But if you get stuck, then alternate them, and hopefully you get the right answer. And if you don't, it's, you don't. But pi over 4 is going to be the square root of 2 over 2. And so I get 1/2 minus the square root of 2 over 2. which is going to be a negative number. And then same thing when you do 7 pi over 4, you'll get 1/2 minus square root of 2 over 2, which is also a negative number. So those will be decreasing. All right. Now the question is asking you for the extrema. So not increasing or decreasing. So where do we have a maximum? What coordinate point? Well, at what x value?
5.
At x equals 5 pi over 3. And where do we have a minimum at? Pi over 3. If you wanted to find the y values, what would you have to do?
But,
Plug into the original, yep. So we're not going to do that, but if you wanted to find the y values, bless you, plug into original. All right, flip it over. Oh my gosh, how are we already 129? Yep.
Because this class is so fun.
Class is fun. All right. I'm gonna have to speed up a little bit. So I'm going to take the derivative. 2/3 x squared minus 4, and now your new exponent is negative 1/3 times derivative of the inside. 2x.
And you set each of the x functions to 0.
So I'm gonna simplify this first. I'm gonna put 4x on top because the 2 times 2x, and 3x squared minus 4 to the 1/3 on bottom. So to get your critical numbers from the top, x equals 0, and from the bottom, you really only need to worry about the x squared minus 4, which gives you plus or minus 2. And so then I'm going to put those guys on my number line, -2, 0, 2. All right, and then for the sake of time, I'm just going to tell you we're going negative, positive, negative. When you test your numbers into the derivative.
How did you do this?
I have my key.
Oh.
So where is there a max at?
0.
0. And where is there a min at?
-2 and +2.
-2 and 2. Alrighty. Let's do this next one. So when I do the derivative here, I'm going to do quotient rule. So low, d high minus high, d low, x to the 4th. Now in this one, I can simplify this by taking an x out of everything. So I think this one was on your thing. I took an x out of everything. So then x times 4x cubed is 4x4 minus 2x4 minus 2 over x cubed, which is 2x4 minus 2.
Are you doing the next one?
If we have time. So x is going to be plus or minus 1 when you set the top equal to 0. And when you set the bottom equal to 0, you get 0. And then once again, for the sake of time, negative, positive, negative, positive. So where do I have a max at? At 0. And where do I have a min at?
-1, +1.
Good. All right, so let's look at the next one. So this next one is a graph. which is actually less math. We're still gonna do a number line.
So we can see the max.
No, because this is the graph of F prime, and I want to know the max and mins of F. Does that make sense?
Oh, that's when it's like.
So first, find your critical numbers. Your critical numbers are when what?
The derivative is 0.
Right, so when is my derivative 0 here?
-4, 2, and 6.
-4, 2, and 6. All right, so for F prime, on the left side of -4, are we positive or negative?
Negative.
Negative. What about between -4 and 2?
Positive.
What about 2 to 6?
Negative.
And after
Positive.
6? So decrease, increase, decrease, increase. So where would F have a maximum at? At 2, and where would F have a minimum at? And 6. Wait, we're not done yet. One more, just one more. Oh, and I'm gonna finish.
I'm not learning anything now, so.
All right. So same thing, this is F prime. And I want to find max and mins. So what are my critical numbers?
-3. Is that -3? What is it?
Sure, let's say -3. Where else? 2, 4,
8.
and 8.
It's really random.
Yeah, I don't know, whatever. All right, so
Positive, negative, positive,
positive, negative, positive, negative, positive. And so when you draw your arrows, I feel like it makes it a little bit clearer. Where would we have maximums at?
-3.
-3 and 4. Where do you have minimums at? 2 and 8.
Now we're done.
Now we're done. So just remember that you have maximums when your derivative goes from negative to positive. I'm sorry, positive to negative. So right here, positive to negative is where you're gonna have maximums, and then minimums go from negative to positive.
Resilient for nothing.